in the given circuit, we have to calculate resistor RC in order to obtain voltage U of t critically damped. So we have to find the critical resistance RC, which has to be plugged in series with the capacitor, that results in critical response of voltage U of t. The switch, which is plugged on the current source, is opening for time t equals 0. Before switching event, the current flows in the left loop. And after switching event, the left loop is opened. Here we have break. So the current flows and supply the right-hand side circuit. In order to calculate voltage U of t, we have to convert the whole system into S-domain. If we want to do this, we have to think about the switch and the current source. So from the right-hand side circuit, it creates a step function of a current that flows here. We have to replace both elements with S-domain equivalent. So S-domain equivalent is J over S, because J over S represents step function. Now we can raise the left-hand side because we are in S-domain, and on the right-hand side we have to create impedances for capacitor. It is 1 over SC, and impedance for coil is SL. In S-domain, circuit is valid for time t greater than 0. We have to replace all elements, as I mentioned before. So now we are calculating capital U of S. Capital U of S is the main current that flows through the parallel branch. It is J over S, the impedance between two branches. The branch with the capacitor and the branch with coil and its internal resistance RL. Numerator, we're gonna have RC plus 1 over SC, RL plus SL, and denominator is a sum of all elements. Now let me multiply and rearrange a little bit this result. In numerator, denominator, let me reduce numerator and denominator by multiplying both by SC. It leads to the following formula. U of S is denominator, and let me rearrange with respect to the highest power of S. It gives S square LC plus SC times RC plus RL plus 1. Critical response of the voltage U of S, characteristic equation, which is here. Calculate delta for the characteristic equation, but for critical response the delta has to be 0. It gives RC plus RL of 2 square root of L over C. Finally, the resistor RC is 2 square root of L over C minus RL. If we substitute by L 1.6 microfarads and by L 100 millihenries, we'll obtain 250 times 2 minus 100. RC is 400 ohms. That's the critical resistance we have to set over here in order to get voltage U of t in time domain critically damped.